2. Friction. Friction opposes a sliding motion or a tendency of motion, and yet friction may also be useful. Opening a bottle and simply walking on the floor are possible just because of friction. Nevertheless, friction often creates trouble as it usually opposes motion. Rolling, lubrication, and air cushion are common methods to reduce friction. When a push is applied to the box on the rough surface, the friction and the applied force are always opposite in direction. They have the same magnitude as far as the box is stationary. Therefore, when a larger push is applied, a larger friction is on the box, trying to keep it still. Until finally, when an even larger push is applied, the maximum friction is reached. And so the applied force is larger than the maximum friction. The net force is applied force minus friction, which produces a forward acceleration in the direction of the applied force, capital letter F. The situation is illustrated in example 10, in which different forces are applied on a box. The size of friction changes in different cases. Please also take a look of part B2. The result may surprise you. Three. Fluid resistance. Fluid resistance is a general term that includes air resistance, water resistance, and even resistance force when a metal ball falls in an oil column. Fluid resistance increases with the speed of moving object, and also the shape and cross-sectional area of the moving object. Streamlined bodies may reduce fluid resistance. Skydiving is a common example used to illustrate fluid resistance and terminal velocity. It starts from the incidence when a skydiver jumps out of a plane. At the beginning, his downward speed is 0, and the weight W is the only force that pulls him downward, producing an acceleration of 9.81 meters per second squared. Soon afterwards, he gains speed, and air resistance increases accordingly. There is a smaller net downward force, and his acceleration decreases at the same time. He keeps falling with acceleration, although the downward acceleration becomes smaller as air resistance keeps increasing with his speed. Finally, he reaches a speed which produces an air resistance that just balances his weight. Then he does not accelerate anymore. That highest possible speed is called terminal speed. The terminal speed of a skydiver is more than 100 km per hour when his parachute has not been opened. He will crash to die if he doesn't have a parachute. Then he opens his parachute. The area increases a lot, and thus the air resistance increases a lot, and becomes much larger than his weight. He now has an upward acceleration. This great upward acceleration decelerates his motion, so that he falls slower. So his speed decreases, and the air resistance also decreases. Finally, he reaches a smaller terminal speed, at which the air resistance equals his weight again. Study the velocity time graph and acceleration time graph on the next page to see if they match what I just said. In example 11, the landing of Curiosity on Mars is used as an example to illustrate the idea explained above. Exam link 2 is challenging. You must spend a couple of minutes to figure out the change in acceleration when a ping pong ball is thrown vertically upwards. Try checkpoint 6 and don't forget to try the MCQs of practice 3.4 afterwards.